Buenos días a todos. Empezamos nuestra charla con Minhyon Kim, que nos va a hablar sobre What Kind of Stories Mathematics. Uh, Thank you for accepting giving this talk, and it's a pleasure to have you here. Um, I, I'm going to say in Spanish that Professor Kim es matemático y trabaja en teoría de números y está en la Universidad de Edimburgo y también se encuentra en el Instituto de Matemáticas en Corea del Sur. Y welcome. Thank you.
Okay, are we ready?
Ready.
Okay, great. Oh, sorry. One question I had. I wasn't quite sure about this. So this is being broadcast somewhere as well?
We are broadcasting to Facebook Live.
Oh, I see. Okay, I hadn't realized that. Okay, that's fine. Yeah, of course. Yeah, yeah. Because I was also going to ask some questions to the audience, but I guess that's not possible. But that's okay. Yeah, I can do without it. Yeah. Anyway, thank you so much for the invitation to speak here. I'll start by sharing my slides.
At
So
the end,
this is
they will post some question probably in the Facebook and we can read it to you.
okay. Yeah, I didn't really know about this Facebook connection. Anyways, so there we go. So this is the title, and I presume you've looked at the abstract. I was quite apprehensive about giving this lecture because, in some sense, I don't have much more to say other than what I wrote in the abstract. Nonetheless, as I was preparing, I built up a kind of a hope that maybe I can say something, elaborate on the abstract a bit. So I will start with a question, which is, well, first let's read the text together, and then I'll tell you what the question is. Well, actually, I can tell you the question now. The question is, can anyone guess where this text comes from? Right? So let's read it together. Unfortunately, there's a number of slides with a lot of text in it, and we don't have to read all of them, but this one maybe it's worth reading. I have always had this urge to question everything around me, and I still do, without being able to do anything to control it, but rather being exasperated by the way it tires my head. I thought that the same thing happened to everyone, as I assumed everyone thought in verse, until my experience disproved this. Now, this trait, whether by inclination or custom, is so ingrained that I cannot see anything without giving it proper reflection. I was once in the presence of two young girls playing with a spinning top, and as soon as I noticed this motion and the shape it made on the floor, I began to reflect in that strange way of mine on the ease with which the spherical shape moved and how the initial momentum lasted, once it had been impressed upon it and then set free from its cause. For having been released from the girl's hand, which caused its motion, the top kept spinning. But I still wasn't satisfied, so I ordered some flour to be brought over and spread on the ground so that when the top spun across it, I would know whether or not its movement would trace perfect circles. But I discovered that instead it made spiral lines which lost their circularity as the initial impulse lost force. So can anyone guess who wrote this text? I wonder. Of course, as I said, I didn't know people would be watching on Facebook, so I can't quite see the answers from there. But maybe the people here, Javier, Mariela, or I guess there's also Bruno. Can anyone guess? Has anyone seen this text before?
Oh, I don't know.
No.
No,
It might be a slightly unfair question. So this is just a nice picture to look at of children playing with tops. It might be even a little bit misleading as far as my question is concerned. So it's a slightly trick question because, in fact, the original text is Spanish. Este modo de reparos en todo me sucedía y sucede siempre sin tener yo arbitrio en ello, que antes me escuelo enfadar porque me cansa la cabeza. I'm not going to read this with my broken Spanish, but anyways, you can get a sense of it. And so maybe this gives you a slightly better idea where this text might be from. No? Okay, so if there are no answers, I feel a little bit foolish talking about this in front of this audience because you see, the answer is from a book called The Answer
Ah, so Juan.
by Sor Juana Inés de la Cruz. And I'm sure everybody knows infinitely more about her than I do. So I feel very foolish speaking about her. She was a remarkable person, of course, as you all know. You can see from these days, she didn't live very long in the 17th century. And as I said, even though everyone knows more than me, I'll just give you a short synopsis of her life. She was an Hieronymite nun of New Spain, and she was a philosopher, composer, and poet. And I've been told that she's regarded often as the best Latin American poet of the colonial era. And she was born near Mexico City, where you are now, and some of you are now, in San Miguel Nepantla. And so, of course, people disagree about who's a great poet, but I've been told that there are few figures that are agreed upon all over Latin America. Sor Juana is one of them, and Ruben Dario is another, maybe, and Pablo Neruda is another. And these three people seem to be very iconic within the region. So she was a child prodigy. By the age of 3, she learned how to read and write in Latin, and by the age of 5, she could do accounts. And by her teen years, she had mastered Greek logic, and at age 13, she was teaching Latin to the children. So in 1664, again, soon after she turned 13, she was apparently sent to Mexico City and became a lady in waiting at the viceroy's court. And she was apparently won the favor of the viceroy's wife, who gave her a lot of what you would call patronage and allowed her to pursue her studies. She joined the nunnery in 1667 and wrote poetry, prose dealing with topics like love, women's rights, and religion. Very famously, she turned her nuns' quarters into a salon visited by New Spain's intellectual elite. So this is supposed the most famous picture of her, which is supposed to depict her in her library, the library she inherited from her grandfather, and was supposed to be maybe the best one in New Spain at that time. Her criticism and her of misogyny, hypocrisy of men, and so on, led to her condemnation by the Bishop of Puebla. So he wrote a text that criticized her under a pen name. He wrote under the name of Sor Filoeta de la Cruz, and brought a lot of criticism upon her, and a lot of pressure started building up around that time. So that book, her answer. That book was a response to the criticism, and you can see 3 years after that book, she was forced to, after she published that response, she was forced to sell her collection of books and focus on charity work. And the year after that, in 1695, she died. Why am I bringing her up? I think it's because you can tell from the text that I showed you that this was certainly a personality for whom poetry and science were somehow the same. I can't really tell about the Spanish, but I'm told that it's beautiful prose that she's writing in. But of course, what she's describing, if we go back briefly, is a scientific experiment where she sees the motion of a top and tries to explain it in some way, even tries to figure out what the curve traced out by the contact point with the ground. This is a very difficult problem, by the way. As far as this contact point is concerned, its motion, it's hard to find good expositions even now, hundreds of years after the fact. And a lot of the ideas that are expressed in here were very new at that time. It's clear that she had contact with the development in Europe, the so-called scientific revolution. Some people say she had correspondence with Newton and so on. Anyways, so what she's doing with her poetry seems to be science in some way. On the other hand, her better known poems don't reflect that very well. So this is actually a very well-known poem, but a very difficult one. So my impression is that it's not very much read even in Mexico. But maybe we should also just read this one together as well. At that great, almost immeasurable height, joyful but perplexed, perplexed but resolute, amazed although resolute, the queen, supreme sovereign of the sublunar world, freely cast the keen gaze of her beautiful eyes of intellect. No spyglass before them. Without fear of distance or mistrust of obstacles, obstacle or concealing object interposed over all creation, whose immense entirety, incomprehensible accumulation appeared clear and possible to the eye, but not the understanding, which, stunned by a glut of objects, his power far exceeded by their grandeur, retroceded a coward. So this is a very long poem, and it's all like this. It's quite hard to read, but it's again her scientific view of the universe, written in poetry. So yeah, her better known poems are like these love poems. I think these are more commonly read. So anyways, I thought I'd start the lecture by introducing this personality and then move on to a story. This is the story of the atom, which many of you read, and I won't tell you. I've prepared a kind of Wikipedia version of this story. And how does it fit? So maybe it won't be so apparent as I'm telling you the story, how it fits in with the way I started this lecture, but hopefully things will become more coherent as I go along. So one story of the atom that's very well known is inside this book. This is by Lucretius, writing in the 1st century before the Common Era, De Rerum Natura, on nature of things. And this is supposed to be one of the very systematic exposition of atomism, the idea that the world is made up of atoms. It was written way back then, but the story goes that it was somehow lost. A manuscript existed, and it was rediscovered sometime in the 14th century and 15th century, and then it became very influential in the 16th century. And many of the architects of the scientific revolution, for example, people like Francis Bacon, are supposed to have been extremely influenced by this poem, by this book. But again, note that this really is a worthy predecessor to Sor Juana's philosophical poem, because this is also a poem. The whole thing is a poem of 700, 400 lines, and a large part of it is concerned with explaining the theory of atoms. So this is a story of the atom in some sense, but I will go on and tell you a longer story. I'm somehow going to show you these characters which come at the end of the story to some extent. Why I chose this character, I don't have a very good explanation. But I've been thinking about this in collaboration with a professor of English for a while. So these are a poet, Muriel Rukeyser, and the mathematician Joshua Willard Gibbs. So I'll tell you a little bit about them. Rukeyser was a leftist poet, a political activist, and she was really central to American literary modernism and to the leftist political communities within the US during this whole period that sometimes, for example, people call the hippie period and so forth. And she also created new forms of documentary poetics in long poems like The Book of the Dead. So this was really a kind of reportage of some sort in the form of poetry because of a disaster that occurred in the construction of a long tunnel called the Hawk's Nest Tunnel, where a lot of the workers, who many of them African American, caught silicosis and with dire consequences. And so the poem is riddled with survival interviews, court transcripts, and other things that are more like investigative recording. So another famous poet, Marilyn Hacker, wrote about her that her poetry could encompass both science and history, that of the past and of the present, from the Depression through the anti-war movements in which the poet was active at the end of her career. So I guess I'm trying to draw a common thread between these two poets, Sor Juana and Rukeyser, because again, both were people for whom which naturally scientific understanding of the world and poetry went together. And I'll show you a quote in a minute. This other person, Willard Gibbs, I guess I'm revealing here how they come together. The first biography of Joshua Willard Gibbs was written by Muriel Rukeyser. It was published in 1942, and I have to say it's a very interesting but very strange book. It's not a standard biography by any means. It's in some sense a rhapsodic intellectual history of America in the 19th century. So I know in Latin America people don't like it when I say America to refer to the US, but I really mean America. And one should understand America in the general sense. There's lots of references to all kinds of people. And certainly Mexico is in North America as well. So this book is very hard to read as well because it's all over the place. It doesn't seem to be telling a standard story of Gibbs. But anyways, it's very much worth reading and trying to see what it is she was trying to say, and especially why was this poet trying to write about this mathematician? What possessed her to do this? And this is what I'm researching with my friend, uh, um, Rowena Epstein Kennedy, who's at the University of Bristol. So here's a short excerpt. Again, maybe this one I won't read to you. I'm reading to you too much long text. But I will call your attention to a sentence in the middle where it says, sort of explains why she's doing this. So she says, the world of the poet, however, is the scientist's world. Their claim on systems is the same. Their writings anticipate each other, welcome each other, indeed embrace. As Lucretius entered Epicurus, Epicureanism was what Lucretius was explaining in his book. So I'll say a little bit more about it later. Gibbs answers Whitman, however, unconsciously and from a distant effort, and so on and so on. So she goes on about this. But she's again a person who feels like a poet and a scientist. Well, they do the same kind of thing. They are somehow trying to understand the world through their work. Gibbs, by the way, I guess I should have told you something about him first, maybe. So he was the first professor of mathematical physics in America. This was in the 19th century, and the system of universities was very different from, of course, from what we have now. So, for example, even after he was appointed a professor for 9 years, he worked without a salary. And there are many things which make it very hard to sort of identify the nature of a professorship in those days. Where for us to relate to the nature of a professorship in those days. But his main achievement, I think everybody would agree, was the creation of statistical mechanics together with Maxwell and Boltzmann. So what does that do? It explains stable properties of matter, the kind of things that we normally see. So we say those things are the normal things having stable properties are systems in equilibrium, but he, together with these other people, explained these properties in terms of an atomic theory. We believe that these things are composed of lots of little particles. How is it that we have these solid objects that have properties that we can feel? So that was his main achievement. As a mathematician, he also created modern vector calculus. So he lived in New Haven near Yale University all his life, and many regard him, as I said, as the earliest theoretical scientist in the US and also the greatest scientist of the 19th century. Well, as Einstein said, he's the greatest mind in American history. Maybe that's a bit of hyperbole, but he certainly was deserving of a lot of praise. Since I'm telling this story, maybe I should say a little bit about what statistical mechanics is about, because even though this is supposed to be a cultural lecture in some way, I can't resist explaining the math just a little bit. Statistical mechanics really is about diagrams of this sort. You've probably all seen this. This is in German because I got it. There was a particularly nice picture in a paper in German. This describes the three phases of water. So this green phase is the normal liquid. This blue phase is ice, and this orange portion is a vapor, water vapor. So when it's in the air, so it shows you how it moves through. This diagram shows you how it moves through these different phases depending upon temperature, which is the axis in this direction, and pressure, which is the vertical axis. So this is around the atmospheric pressure over here, this line. So at that point, for example, you know that water goes from liquid to vapor at 100 degrees Celsius. It goes from liquid, then if you drop the temperature, it turns into ice at that pressure. On the other hand, if you have very high pressure, it remains a liquid even at much higher temperature. So these kind of things are all phenomena that are experimentally well verified. This diagram is a much more accurate diagram, by the way, than the ones that you'll see in a lot of textbooks. So it's a fairly recent experimental diagram. But of course, from an atomic point of view, this is very mysterious because they're all made of exactly the same things. So how come it has these different states? And So statistical mechanics is about explaining this process. So I put some text here to try to explain. I hope it makes sense. So the question in some sense is, how is it, if since we all believe in atoms at this point, how is it that this swarm of particles that are moving all the time and changing their state, it still results in objects with stable properties like a block of ice or a piece of iron? And so Gibbs was among the first people to clearly see that our perceived reality of an object in equilibrium is actually probabilistic. So what do we mean by that? Even though the system is moving through all different states, the probability of being in any specific state remains the same through all this complicated motion. And so somehow the system cycles rapidly through a lot of different states, even us, a block of ice, a piece of iron. But in fact, the amount of time it spends in each state remains the same, and it's distribution of duration that makes up our perception of things as they are. You might compare this. One comparison I like is to listening to a musical note. Right? As you know, musical note is a rapid fluctuation of air pressure that hits our ear, right? But we don't hear the fluctuation. We somehow perceive the speed of the fluctuation in terms of the pitch, right? So that's similar to how the properties change corresponding to the pattern of the fluctuation. And these are the people that explained it in mathematical form. So this is one last slide. I'll tell you about this story. These are the four noble gases: helium, neon, argon, and xenon. And so if you look at this slide down here, for example, this is helium. And it tells you how the speeds of the helium of a block of a room full of helium is distributed. Or even a box of helium when it's at room temperature. Most of it, a lot of it rather, will be moving around 1,200 meters per second. But there are lots of other bits of helium, of the gas, that's moving at other speeds. If you go to a slightly heavier object like neon, then the peak of the speed distribution is around 500 meters because it's heavier. Everything tends to move slower. But there are some of it that moves faster than helium and so on. It's just this distribution that's changing and so on. Then the point is that our perception somehow sees this distribution. And that's what we perceive of as temperature. In fact, it's this distribution that translates in our perception into temperature. So this was statistical mechanics, which was established towards the end of the 19th century. So I said this was a story of atoms, and that was essentially the end of the story. So the rest of the story I'm not going to read to you in any way. I just put it here so you can glance at it and see that it's very, very complicated. So for example, one of the very earliest reference to the idea that matter is made of tiny objects appears in the writings of the Vedic, well, it wasn't writings because a lot of this was transmitted by words as well, verbally. But anyways, written down later. So all of these dates are very uncertain. But the Vedic sage Aruni is supposed to have spoken about objects being made of kana, which are nowadays translated as particle of atom. And then there's a lot of the rest of the story that follows. Of course, whether they should really be viewed as an atomic theory or not is a subject of much debate. But that's true even of later authors. At which point does it really correspond to something that we would call atoms? The idea that large things are made out of small objects might be natural in many different forms. So it's all very unclear anyways. So it's kind of a story that's complicated. And of course, as many of you will know, even while atomic theory was coming out, there were lots of people who objected long ago as well. Plato thought that atoms just couldn't explain the beauty and form of the world, so somehow unchanging reality of mathematics is more basic than any idea of atoms. And Aristotle, on the other hand, thought that objects were continuous. They're not just broken down into discrete packets. And then the story goes on and on and on. So Buddhist philosophers wrote about it, Roman philosophers wrote about it, Islamic philosophers wrote about it. One interesting thing is that Al-Ghazali of the Asharite school seems to have wrote about atoms fairly specifically. I haven't read it myself. This is just from an encyclopedia. But then other people from like Averroes, who came after, who was a bit younger than him, didn't believe, well, I guess a good deal younger than him, but he didn't believe in atoms, so he rejects atomism, and Al-Ghazali believes in atomism. So there is this dialectic going on in Islamic philosophy as well. One interesting thing here, by the way, is that nowadays, when we look at it from an outside eye, Al-Ghazali is often viewed as the more conservative thinker of that period, and Averroes as being the more forward-looking. But all of that is very, very complicated, as you can see from this story, because Averroes is more backward as far as the theory of constitution of objects is concerned. I'm sure a real scholar will tell you a much more complicated story. So anyways, it goes on. So I won't tell you more of it, but just let you glance at this controversy along the way. There were also people like this Ragusan polymath, Roger Boscovich, who isn't very well known, I think, but he seems to have provided the first mathematical, a version of a mathematical theory of atomism. So Ragusa, by the way, the Republic of Ragusa is in current day Croatia. It's one of these vanished nations or political entities. So anyways, so after all this complicated story in the late 19th century, statistical mechanics is founded by Boltzmann and Maxwell and Gibbs, and this really makes it possible to believe in atoms some way. Because people, it seems, had been aware for a long time that it's very hard to square our experience of objects with the idea that it's made of all these particles. Right? So the statistical mechanics was the story that made this plausible, even though even at this point there were lots of critics. So for example, Boltzmann is partly supposed to have committed suicide because he was surrounded by people who didn't believe in it. But then in the 20th century, Einstein publishes his theory of Brownian motion, and the quantum mechanics comes around and so on. So things nowadays, everybody believes some version of the story of atoms. Yeah, so far, I've discussed Juana de la Cruz, Juana Gines de la Cruz, and then Muriel Rukeyser, and the science surrounding them in some way. So what am I trying to say? I've already said it in some sense, but I try to bring it together at the end and hope that my exposition doesn't become too disjoint. But in the abstract, I also said something about economics, right? So maybe I'll do a little bit of mathematics related to economics as well. And then after that, we'll return to the question of the title. Because I think this is also a very important illustration. This story of economics is an illustration of this complicated interaction that's the subject of this lecture. So so this is mostly about something called game theory. Sorry, I should have put it in the title of the chapter somehow. But there's a famous game called Battle of the Sexes, where people try to spend an evening out. So there are these two characters, Juana and Octavio, and they have to decide on where to spend their Friday evening. So Juana would like to go to a philosophy lecture, while Octavio would like to go see Club America play. On the other hand, they would rather be together than alone. They have different preferences, but they would rather be together than alone. So here, I created a little diagram that explains their possible choices. So here, these are the choices of Juana and Octavio. They're just the same, so I'm putting Juana's choices along the vertical column here, and this horizontal line is Octavio's choices. They can either choose to go to football or philosophy. And then, corresponding to their pair of choices, I've put the pairs of what are sometimes called strategies or actions inside this square here, which is a matrix, of course, in mathematical terms. So this thing corresponds to the choice where Juana goes to philosophy and Octavio goes to football. This is where they both go to philosophy and so on. This isn't a full specification of the game. In game theory, what they do is they give you something called a payoff matrix, utility, or something you might interpret as a level of satisfaction corresponding to each of these choices. So here's an example, right? So what I'm saying over here, right? So what do these mean? So this 2 comma 4 is the level of satisfaction of each of these two agents. So Juana is being given level 2, and Octavio is given level 4, corresponding to the choice football and football. If they both decide to go to football, Juana gets a satisfaction of 2 and Octavio gets a satisfaction of 4. So that's what this model is telling you. On the other hand, if they go to the philosophy lecture together, then Juana gets 4 and Octavio gets 2. So this somehow, of course, their payoff is being reversed according to these two pairs of strategies or pairs of actions. On the other hand, if Juana goes to philosophy and Octavio goes to football, that's this corner over here, they both get a satisfaction of 1. And that sort of makes sense because they're not together. They would really prefer to be together. On the other hand, at least they're going to their preferred venue, right? But if Juana happens to go to football by mistake, hoping to see him, and Octavia goes to philosophy, of course, neither of them get any satisfaction at all. So this is a model. You can change the numbers, which still reflects the same model, more or less. Conceptually, doesn't change the situation, but it's supposed to reflect the way the satisfaction turns out corresponding to these choices. So this is the game theory is specified by giving this collection of possible choices, possible actions, and the payoffs corresponding to them. So what happens in practice? So this is a very, very simple example, so maybe it's even slightly misleading. I've just reproduced the table here. What do they say in game theory? That portion of economics called game theory, they try to explain the behavior observed in nature as being equilibria of certain sort. In other words, where forces are being balanced out. The thing that's particular to this kind of games, strategic games, the principle that economists believe in at some level is that the observed strategy form a Nash equilibrium. What is that? A Nash equilibrium is a pair of strategy with the following property. This can be kind of complicated. But I realize I'm saying things rather quickly. If you've never seen this before, I hope it makes sense anyway. A Nash equilibrium is a pair of strategy with this property that neither side can improve their situation by changing only their own mind. So we don't consider at the moment them discussing and try to change the other person's mind. Just consider the possibility that they change their own mind. Right? And can you improve your situation or not? If neither side can improve their situation, then it's called a Nash equilibrium. Well, let's look at this example. Suppose you're over here at the football corner, right? Then Juana has a payoff of 2 and Octavio has a payoff of 4, right? Now, Octavia's choices correspond to moving in the horizontal direction, right? If Juana's choice remains at football and Octavia's choice changes, then you move from between these two squares, right? These two locations. So you can see that if only Octavio is allowed to change his mind, then his payoff will go from 4 to 0. So obviously he doesn't want to do that. He can't improve his situation. What about Juana? Of course she prefers philosophy to football. On the other hand, if only she changes her mind while Octavia's choice remains constant, then you drop to this square over here, right? So her payoff still decreases even though she's at her preferred venue because they're no longer together, right? So you can see, according to this definition, you can see that this point is a Nash equilibrium. You see? Neither side can improve their lot by only changing their own mind. The exactly same reason will apply here with the 4-2 slot philosophy action pairs. They neither will be able to change their lot, improve their lot by changing their own mind. On the other hand, suppose you're over here, right? So here, both Juana and Octavio are at their preferred venue, right? But assuming the other person doesn't change their mind, right? Still, Juana can improve her satisfaction by going to football, right? Because she goes from 1 to 2. Similarly, Octavio can change his satisfaction by going to philosophy. Right? That moves from 1 to 2. So somehow, this is not a Nash equilibrium. So these two are Nash equilibrium. This is not a Nash equilibrium. You can easily see that this one is also not a Nash equilibrium. That's the way this reasoning works. This is the nature of Nash equilibria. So for this game, football, and philosophy are Nash equilibria. Okay? I hope that notion makes sense. So even the people watching on Facebook, if you have questions, please post it somewhere, and the host said that they will let me know. I hope this makes sense. So here's another game which is slightly funny. I prepared it because it has some humor mixed in it. This is the game of household economics, where again, now they've gotten married, Hona and Octavio, and they're trying to form a household. And in managing the economics, the finances of their home, they can both choose one of two strategies, either save or spend. Okay? So this is the two possible actions for both Juana and Octavio. So let's look at this payoff matrix. So what happens here is that if they both save, they both get a satisfaction of 3. On the other hand, if Juana is saving while Octavio is spending, he is very happy because somehow he can rely on Juana's savings to have more fun himself. But of course, she's not so happy about it, so we've modeled that level of happiness or satisfaction as 1,5. Octavio has level 5 and Juana has level 1. And if you do the opposite, if Juana is spending and Octavio is saving, it reverses. So she has satisfaction level 5 and he has satisfaction level 1. If they both decide to spend, I put the payoff at minus infinity, because it's kind of ruination and nobody wants that. Right, so if you look at this situation, so here's what happened. Suppose you're over here at 5, 1, right? So what are we trying to do? So with, maybe I should have drummed this in at the beginning, with game theory, at the outset, so there are more complicated problems you have to solve eventually, but at the outset, in beginning game theory, the question always is, presented with a game like this, what are the Nash equilibria? Yeah, so you try them one by one, then you eventually learn other techniques to deal with this problem more efficiently as well. But initially, you just look at them one by one. So let's look at this corner 5, 1. Well, you see, if you're in this situation, Juana, if she just changes her mind and wants to go from spend to save, then you see her payoff decreases from 5 to 3. Right? So that's not good. So she would not want to change her mind. What about Octavio? Well, he's at 1, but if he just changes his mind, his payoff will go to minus infinity, right? So he doesn't change his mind either. So you see, this is a Nash equilibrium. Same thing over here. Even though it's obvious, it's repetitive, I'll just say it again. If you're over here, if Juana just changes her mind, she's not so happy because, of course, he's spending and she's not. But if she changes her mind, then her payoff goes to minus infinity. So that's not very good. Yeah? And if he changes his mind, he's very happy living off Juana's savings, of course. So he's not going to change his mind and change his payoff to a 3. So the point is, these two are Nash equilibria. What about this one? Well, so this is the difficulty here. Here they both have reasonable level of satisfaction, right? But Octavio will want to change his mind because if he just moves to the spending option, then he goes to a 5. Similarly, Juana will want to change her mind because she goes to a 5. So both of them want to change their mind, assuming the other person doesn't, right? So again, with this assumption that you're only controlling your action, you can see that this is not an equilibrium. So these two are Nash equilibria. And it's mildly amusing because after you see observe married couples for a while, this is actually a very, very common pattern. One person tends to save and the other person tends to be a spendthrift. That's very common. And you can see that if both of them are in this saving corner, the temptation to change for one person to change their mind is very strong. But once you're fixed in a corner like this, you can't go back because of this equilibrium properties. On the other hand, you might think that Juana wants to change her mind and wants to become a spendthrift herself, but she refrains from doing this because then they'll just go broke. So you might say there's kind of a common situation that's reflected in our model of the game and the principle that Nash equilibrium is what should be observed. Right? Well, so there's one other game here, which actually maybe I won't go over this game. I wanted to say something about Nash's theorem, but maybe it's better to save some time and talk about this a little bit more. Well, so if you look at models of actual human action and equilibrium strategies like this, so what is one to make of it? Some people will say, well, this is not really science, of course. This is because this kind of model involves enormous amount of simplification, right? You're idealizing a lot of this and focusing just on two very simple-minded choices, save and spend. And some other people might say, well, this doesn't really predict things either. I know plenty of frugal couples who both save, right? And then I know plenty of couples who just break up because they can't convince each other to spend, to save. So a lot of things happen. So you can't really regard this as a predictive model of the world. And since some people like to think of science as constituting somehow predictive models or precise explanations, this doesn't seem very much like a scientific theory. Right? But, so this guy, Ariel Rubinstein, was a very distinguished, oh sorry, so this is a picture that I just wanted to show you that people were really fascinated by this at some point. So John Nash, who formulated all these notions, received the Nobel Prize in Economics, and there was a famous book written about his life and then a consequent Hollywood film. So Ariel Rubinstein was a very famous game theorist. He likes to say economics is a story. And as far as I understand, he means two different things by this. One is that he wants to say economists should be humble. They're not really doing science. They can't give precise explanation of social phenomena. They can't make predictions. So they shouldn't pretend they are. So he does really advise humility on the part of economists in this regard. So that's one sense in which it's a story. But there is another sense in which he's using this idea, or he's propagating this sentiment, let's say, because he really likes literature. He says that his favorite author is Chekhov, and he often says that he wouldn't be doing economics if he could write stories like Chekhov. And the point, I think, is clear, that a story, well-written stories like a well-written novel or a short story, definitely tells us something about the world. It's not so easy to say what it is we learn about the world, or what morals might be drawn, or what kind of a guide to action they might give. But almost everybody, when they read great piece of literature, feel like they learned something. That's what we mean roughly by a great piece of literature. And I think that's what he means as well when he says economics is a story. When you look at models like this, again, it's nothing like a scientific theory, or well, not in any obvious way, but if you look at this and it feels like it gives you some insight on social phenomena. And a lot of economics is like this. It's not about making precise predictions or giving precise explanations, but it teaches you something about social phenomena, gives you insight that seems applicable in a more complicated sense than Newton's law of motion or something like that. So that's what I think. These are the two meanings I think he intends with this idea that economics is a story. Okay, yeah. So I think we're approaching the end of the lecture, and it's possible I rushed too much. Well, let's see how this goes. Right? So what kind of story is mathematics? So that was the title of my lecture. It might surprise you that I intend to give an answer. I somehow started out like I'm just going to talk around this question, but in fact, I will try to give an answer. But when one raises a question like this, so I've had a few conversations now while preparing this lecture, all kinds of questions about mathematics come up. So for example, this is a list of questions I will not address. There were more questions, almost a continuous stream of questions, which were elicited by discussing this one, right? But it's just a kind of random, haphazard list. So some people like to know, is mathematics creative? Is that what I'm going to talk about? Is the history of mathematics a story? Is expository power important in mathematics or mathematics education? Is mathematics discovered or invented? That's a bit of a chestnut, right? Is mathematics concerned with correctness? Is mathematics concerned with truth? Does mathematics give absolute certainty? Is mathematics logic? So these are all questions which somehow seems to be related to the question I asked. Right? And I'm not going to talk about this, even though I'm not saying these are not interesting questions. They are. They can be interesting questions, and they all have obvious answers, sort of. So, but I'm not going to talk about them much. Well, maybe I will be alluding to them in some curious way. However, in order to answer the question that I posed, there's probably one question that I can't run away from, I can't avoid, and it probably already occurred to you. In fact, is mathematics a story? Somehow my question takes for granted that it is, and then I'm claiming, I'm asking what kind of a story it is. So you might wonder, in fact, is mathematics a story? So I won't address this question too much myself, but I will tell you why I think it is. So first, let me start with a quotation. So here it says, yes, mathematics can be viewed as a story, especially when considering the history of its development and the narrative surrounding its concepts and discoveries. While mathematics is also a rigorous system of logic and theory, its evolution is filled with tales of ingenuity, struggle, and revelation. And this quote goes on to a categorized collection of reasons why mathematics is a story. So like the question that I started out the lecture with, I'll ask here a question again. And can anyone guess where I got these quotes? This is all one source, by the way. I said quotes, but it's one quote. It's one source. Can anybody guess? Javier, do you have any idea where I might have got this?
I'm reading now.
No. Mariela?
Gabriela maybe knows.
Do you know? By any chance? No?
Oh, I know.
Yeah, yeah, not sorry. Bruno, you've unmuted. Do you have a guess?
I don't know, maybe Gardner or something like
Sorry,
that.
maybe.
Gardner or something like that.
No,
Sure.
no, 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 that's not a bad guess. Yeah, yeah, sorry about that. I'm sort of embarrassing people deliberately by asking this question. This is ChatGPT. This is from ChatGPT. So it's slightly funny. Well, no, they give an answer to a question like this. So at least I know that ChatGPT agrees with me. But these categorized reasons are kind of interesting as well because it's actually not addressing the question. So this is kind of the kind of error that, in some sense, that ChatGPT produces. All of these categorized reasons that is saying mathematics is a story is not about mathematics itself. It's telling you, for example, that the history of mathematics is a story. It's also saying that you can make conceptual stories around mathematics, like when we give students word problems. It also tells you that there are certain kinds of fiction that are inspired by mathematics. I think Sarah Hart must have talked about such things. And so there are many things like this, but none of them is telling you that mathematics really, this categorized collection of reasons is a little bit poor, even though I'm happy that ChatGPT agrees with me. So it's not really answering this question, but is mathematics a story? And I'm just going to give a very simple answer without explaining it much. I said, I'm saying mathematics is a story because both the goal and of mathematics and of literature is really to understand the world by way of stories. So the mathematics we weave to take apart the world really is a story of some sort. That's what I'm claiming. And I'm just going to tell you, defend that position in some sense by not directly explaining this answer, right? But just telling you the kind of story that I think it is, and thereby trying to make this answer convincing. So this is just a picture of an article by this linguistic anthropologist at the University of Sydney. It's a very common view, of course, how stories help us make sense of the world. So in any case, in fact, I tend to view that as being the primary function of stories. And other people may not entirely agree, but maybe everybody agrees enough for me to be able to proceed with this lecture. And in any case, so I think mathematics does tell story as a way to understand and explain the world.
But the question is, physics, for instance, is the same way, right?
Exactly. That's exactly what I'm saying. That's right. So So physics is the same, economics is the same. So I'm using this. So that's actually a very good point. I should have emphasized this. So the way I'm describing the sense in which mathematics is a story applies to economics, because of course this lecture was inspired by Ariel Rubinstein's claim, and of course to physics and a lot of other ways of theoretically thinking about the world. No, I completely agree with that. They all have different modes of doing this, so we may think of them there as very different. But I think there is something to the notion. I think, I'm more and more tending to believe the notion that they're all telling stories of somewhat different. So I'm just going to tell you what I think the story of mathematics is. Okay. Any other objections at this point? Mathematics, physics, economics, and literature, they all try to understand the world by way of stories. Okay.
Theoretical physics, right?
Theoretical physics, that's right. And that interacts with experiments as well. Well, mathematics also interacts with experiments all the time, of course, right? So if you have Pythagoras' theorem or something that you can view that as coming out of Euclidean geometry, where Euclid wrote down some things that it should be obvious in the world, then you can go test triangles and see if they really work or not, right? So we can do a lot of experiments. More complicated thing is like Euler's formula for convex polyhedra. We can experiment all we want, and it's fun to do that. And so there's the experimental part of it, but that goes together with a story that tries to tell you what kind of explain experiments and also tell you what other experiments might be interesting. In number theory, it's very, very common to do this. Okay, other questions or objections?
Well, you're assuming that mathematics is, you are a Platonist, right? I mean, you are a realistic.
Different people.
Because if not, doesn't make sense, that, right?
Say again?
If you were not a Platonist in mathematics, so probably this is not true.
Why do you think so?
Because it's going to be a language only.
Why
a language is not a story, right?
Physics uses language, economics uses language, mathematics.
No, they have their own language. But if you think mathematics is not, if you're not realistic in mathematics, if you don't think the mathematical object exists outside of your mind, then mathematics is a language only. And therefore
mathematics is a language, but I just object to the idea only. Do convex polyhedra exist?
No, what I mean
Obviously,
is,
yes, right?
okay.
One can be very, very philosophical and theoretical about it and try to reject this in some way, but I don't find it convincing at all. Convex polyhedra exist. Surfaces of higher genus also exist. What's the problem? And then we find stable properties that they have.
No, I am observing that in order to mathematics to be a story, to understand the reality, is because mathematical objects exist outside of my mind.
So, well, as I said, the theories we've constructed interact with our minds in a complicated way. That's the same with physics, right? There are various theoretical constructs and so forth. Of course, it interacts with the world. When Euclid was writing about lines and points, of course, he thought these were properties of lines and points in the world. And so somehow, okay, so that's a very, very long story. So maybe it'll be hard for us to go into this right now. But I made one response to your question was, you don't have to be a Platonist to talk about the things I'm talking about. It doesn't have to intersect with Platonism in any significant way. That's one thing. And secondly, this point is a slightly more subtle point, and I probably won't explain it. And I think, but however, any mathematician who thinks about it, I think will agree with me eventually. It's this, that a lot of philosophers like to argue that about Platonism or whatever, and they like to argue that mathematics isn't part of the real world, whatever that means, right? But if you examine the arguments that philosophers give that mathematics isn't real, all of them are circular. Any that I have that I have encountered are circular. In other words, you conclude at the end that mathematics isn't part of the world, but somewhere along the way you've already assumed somewhere along the way that it's not part of the world. That's my view. So as I said, if you examine philosophers' arguments and think about it for a while, I'm reasonably convinced that most mathematicians will agree with me if you think about it. Anyway, so that's a bold claim, but maybe we won't touch on this complicated subject of Platon or talk about this too much more. Is that okay? Javier, do you agree enough for us to proceed?
I agree. It's a long discussion, yeah.
But think about my claim about this. Examine people's arguments that mathematics isn't part of the world and compare it with the idea that physics isn't part of the world. This comparison isn't carried out carefully enough by philosophers, by the way. Anyways, so, okay, shall we move on then? So maybe one warning in some sense. Why do sometimes people resist the idea that mathematics is a story? There might be many, many reasons, right? But one of them, which I find rather interesting. Oh, sorry, maybe I'll skip this. I was going to just quote somebody who sort of disagrees with my view that stories are about understanding the world, but I'll skip that. That it's because this admission that mathematics is a story does come with hazards, right? Because people do feel like when I say something is a story, when we think about great literature, it has positive connotations, right? But story can have many negative connotations too. And in the political realm, people point to this and accuse each other of making up stories all the time. Right? This is a relatively recent book about the dangers of narrative by this comparative literature professor, Peter Brooks. And again, if you go to a little discussion on Facebook or something, people will also say, well, that's your narrative in order to dismiss it or something, right? So the idea that stories can be used to distort reality is a common one as well. And we may have to acknowledge that mathematics is subject to the same danger if we claim that mathematics is a story. So I'm not denying this actually myself. And in fact, people have levied this criticism against mathematics. So for example, this is a very famous popular physicist. She does a lot of public communication in physics. And she wrote this book, Sabine Hossenfelder. I don't agree with a lot of things she says, but the thesis of this book is interesting. She said the title is Lost in Math. And what she's trying to argue in here is that somehow this beautiful story of mathematics has led physics astray. It has nothing to do with reality. The kind of mathematics that generates the kind of physics like string theory especially is her main example. And she believes that the beautiful mathematics that generated string theory has led physics astray. So this idea that mathematics can give rise to dangerous narratives is not an uncommon one at all, even among very serious scientists. So here's another one. So this is from economics. This is from a quote from the very famous economist, influential economist, Paul Krugman. He says, "Math is a friend of mine. There have been a number of occasions in my life when doing the math on an economic model has led me to conclusions very different from my preconceptions, but I have always been able after the fact to find a way to express in plain English what the math is telling me. If you resort to math to justify what looks like a very foolish claim, and you can't find a plausible way to express that justification in plain English, something is wrong." Well, so he was also famous for blaming the financial crisis of 2008 on mathematical models. So, okay, you can. This will again be a long story to argue about this, the pros and cons of this opinion. I'll just share with you a commentary from my friend Jordan Ellenberg. He said, well, this might be compared to the following sentiment. Music is a friend of mine. There have been a number of occasions in my life when a piece of music has conveyed to me a powerful emotion or sensation, but I have always been able after the fact to express in plain English the way the music sounded and the way it made me feel. Okay, so those are all preliminaries. Now finally, let me give the answers that I prepared. So after this as well, you can agree, disagree, and I really invite criticism. But I did try in my own way to pare this down, my answer to this question down to 5 characteristics. So one, Javier already alluded to, and maybe other people will notice this obvious thing as well. Of course, in mathematics, there's an extension of language, right? No matter what your mother tongue is, so to speak, or even if you speak several languages, mathematics does require a substantial extension of that. And that's an obstacle, of course, to a lot of people who try to learn mathematics from an early age to adulthood. Here's an illustration of it. This is an example from Diophantus's Arithmetica. He says there's a problem that he poses to divide a given number into two numbers such that their product is a cube minus its side. So this already probably incorporates a lot of mathematical terminology, which then eventually became more common. Of course, there's this complicated interaction between mathematical terminology and common language as well. But still, we don't express problems in this way anymore. We write the same problem like this in modern mathematics. So this is a substantial extension of language and notation beyond even what Diophantus was using. So that's one key characteristic, I think, of mathematics. The second of the stories that mathematics is, and of course, another obvious thing is that to read the story of mathematics or to write it requires, of course, makes unusually large demands on faculty of reasoning. We know that sometimes it requires days to get through a page or even one line of text. Maybe it's not so well known to non-mathematicians that mathematical readers don't always read so carefully. Of course, we don't have to understand things thoroughly the first time around. So there are lots of times we're just skimming things and using that as for a vague understanding that might be useful anyways, and maybe returning later to a more careful understanding or not. But in any case, of course, at any level, mathematics, to read it, the story of mathematics makes large demands on the faculty of reasoning. And, well, we said that literature, physics, mathematics all give you knowledge about the world, but of course in mathematics there's a high level of precision in the long knowledge you gain about the world. You can't really say this about fiction, say a novel, right? You can't say that what you get is precise knowledge. And I'll say more about this in concluding. By the way, I see I've essentially run out of time now. I'll conclude very soon. I hope you will forgive me. So, for example, if you compare an observation like saying an asteroid goes around the sun versus an asteroid follows an ellipse, right? So the second sentence is a much more mathematical one, and it gives you a lot of precision in your knowledge, right? Because just by knowing this, you know the fact that 5 points on an ellipse completely determines the ellipse. And this was very important for people to be able to, say, trace the trajectory of asteroids when they were first discovered. You only make a few observations that tells you where to look for the asteroid forever afterwards, right? So that's the kind of precision that in knowledge that's gained from mathematics that you don't gain from literature. So now this point, again, is probably not very well known to non-mathematicians, that the writing and reading of mathematics is extremely communal. What do I mean by this? Well, there are many, many meanings to this, but I've just excerpted 3. So, for example, all stories are overtly patched together from many other stories. If you look at a mathematical paper, it will refer to lots of others and say that, well, that person said this, I'm going to use that part of the story and then patch it together to some other story of my own. That's a communal aspect of the writing of mathematics. And when you read mathematics as well, of course, it's read together very much. Much of mathematics is so difficult that it's very hard to read by yourself, and many people share their experience of reading and the different levels of understanding they've gained by this process of reading. And so this is another communal aspect in the reading part of mathematics. And then another aspect is that satisfactory vicarious reading is common and it's very valuable. Somebody else may read something, right, and tell you roughly what it's about. It's hard to get satisfaction out of that in literature, but in fact that can be very, very valuable in mathematics, right? So these are all 3 and many other things reflect the communal aspect of the creation and the reading of mathematical stories. So this is the 4th characteristic. Finally, the 5th characteristic is that good mathematical stories are never ending. And this is almost by definition. When we judge a piece of mathematics to be good, somehow it's when we see a possibility of continuing on to richer stories, richer pastures, and a deepening of understanding for which the given story is just a signpost, a temporary stopping point. So these are the 5 characteristics of mathematical stories that I decided on as an answer to the question in the title of the lecture. So I will finish. Yeah, so we can debate about that later, but if we have time, if you allow me time. But I will finish with one last commentary about these answers that I gave. So when you think about the epistemic value of mathematical story, you might say the precision comes from a very reductionist approach. So mathematics has very much to do with breaking apart arguments into constituent pieces, taking a sentence and asking ourselves what each part means, how do they fit together, and so forth. So it is very much in the tradition of reductionism, which people like to think characterize modern science, right? And you might say by comparison, what you gain out of literature is much more holistic. Reading a great book, say about um, Morocco, a great novel about Morocco, in fact, may give me a lot of knowledge about Morocco and even tell me how to act if I happen to visit to be regarded as a civilized person, right? But exactly what you gain out of it is much harder to tell. It's more of an entirety that you get out of reading this novel. So even though these two words, reductionist and holist, are abused very much in the kind of philosophical and pseudo-philosophical literature, I will use it here to characterize the different kinds of epistemic gains. But in this sense, what occurred to me as I thought about this distinction is that the knowledge gained in literature appears to be very close to artificial intelligence in that sense. So you see, what AI does for us when it gives us answers to questions, so for example, or is able to solve problems and so forth. So of course, scientists are very frustrated by the fact that they can't understand this process in reductionist terms. But it did occur to me in a curious way that there's something very interesting and maybe even valuable about it. Maybe it's possible that the epistemic gain or the problem solving ability of artificial intelligence even is somewhat like literature. Right? Maybe I will illustrate this one other example from outside of mathematics. So this is a kind of a friend of mine who's the CEO of the Luxembourg Institute of Health. So he works on pharmaceutical with pharmaceutical companies and with the government to develop drugs and come up with new diagnostic procedures and so forth. So last time I met him, he tried to sell me this slogan that voice is the new blood. What does he mean by this? Well, he's very optimistic about the potential of AI for healthcare. And the way he phrased, so one of those things, one specific example is that apparently just by listening to the voice, AI can diagnose all kinds of things with fairly high degree of accuracy. For example, I think he said that type 2 diabetes can be diagnosed with more than 95% degree of accuracy without a blood test. So blood test you can say view in this context as a reductionist method of diagnosing because you measure various levels of chemicals, right? Voice is saying we don't know exactly how it works. We seem to be able to do it. So he's very optimistic about the possibility. And from a certain viewpoint, the way you can couch this in the framework, the AI healthcare is in fact very holistic. So we may someday come up with a better reductionist understanding, but maybe it won't even happen, but maybe it will be okay. I don't know. This is a difficult way of thinking about the future. But in any case, he also points out that reductionist healthcare is actually far more limited than is usually acknowledged. There are some things that it's very good at, but in fact, lots of things, problems, human healthcare problems that it's not able to solve in spite of the great advances in medicine that have been made. So the ending question, I posed a lot of questions and answered one very difficult one in my own way in this lecture. So I'll end with the following last question, which is, well, we know that we're going to use a lot of AI in mathematics as well, right? So is it possible that AI aided mathematics will become increasingly holistic? I won't explain that question anymore in any more detail, but I think it's an interesting question. So somehow, let's say, so holistic knowledge, for example, holistic healthcare, has always had this weakness of being regarded as somewhat unreliable. It seems to work sometimes, and sometimes people get reliant on it in some way. But the probability of success is often very low. By the way, reductionist medicine is also like that often. It's not as though reductionist medicine is highly reliable in all aspects. But in any case, holistic medicine exists all over the world. But that's an example of various holistic accounts of the world that don't seem to be very reliable. But somehow AI seems to provide the possibility of holistic stories that are reliable. And this is kind of a remarkable development in a way. And it's possible that some aspect of this will be reflected in mathematical stories of the future. Okay, thank you very much. I'm sorry for going over time.
Hi, thank you, Minhyon. It's been very nice to listen to you to all these ideas. And I I don't think there are too many questions from the public in Facebook. Someone is asking about a book of history and mathematics, but
Sorry, a
I
history book of mathematics?
yes, he or she is asking about this book, if which was the name, and but I don't I cannot tell in
If
which
you
part
can
of the
recommend one,
Sorry?
yeah.
if you,
Would I recommend one?
yes.
It depends on the person's background. One wonderful book that I know about, which all mathematicians or people interested in mathematics education might read, is a book called History of Mathematical Proof in Ancient Traditions. And this is a collection of essays, and the editor is named Karin Chemla, Chemla.
Can you be some kind to in the chat in Zoom? Could you write down the title and the author, and we can just paste it
Sure.
in Facebook?
Hang on. Let me see. I forgot. Maybe I have to stop sharing to do this. Um, oh. This is a book that debunks a lot of misconceptions around proof.
Now, there is a question by Bruno there in the chat.
No, I see that. Most mathematics only describe reality. I think in many aspects, mathematics is a language that might describe different kinds of reality. Of course, this is true. This is true of physics as well, by the way. So there are always theoretical portions of any theory of the world and things that touch more directly on aspects, on palpable reality. So, and the boundary is, of course, very indistinct. No, I think it can describe a lot of things that are not directly real, but this is true of literature, of physics, of all kinds of theoretical, all kinds of accounts of the world that have a theoretical component.
Well, that's a hard question because we have to define what is reality.
Of course, and we're avoiding that. And anybody who says mathematics is real or not real, right, avoids that question as well. And it's almost impossible to ask that question. But that's the basic problem of this discussion, that definitions, there are no final definitions. We know that as mathematicians. We try our best to make things clear. There are no final definitions. But nonetheless, talking about things with some understanding that we know what we mean still seems to clarify matters in some way, right? And that's what we're hoping for. We're not claiming that we have definite definitions of reality, mathematics, story, any of these concepts that have come up. That's just the nature of our language and also of our own understanding, right? We have to accept the fact that everything is sort of unclear, of course.
Now, if I understood correctly, economics, mathematics, physics, literature, they are stories, tell stories, but is did you find something in particular in mathematics that you don't find in the other science or disciplines that is related with literature?
Well, I gave my list of 5 characteristics. So that's sort of my attempt at answering your question. And I'm not sure that it's entirely different, right? But it's a lot of these things are questions of degree. So, for example, I mentioned that mathematics makes large demands on the faculty of reasoning. If you read literature as well, some novels clearly require you to focus much more and reason much more clearly than others, right? If you read Stephen King, that's much easier to read than War and Peace or in Latin American literature. maybe some people will disagree with this, but if I read Marquez, that's still much easier to read than reading Bolaño, for example. And there's a very varying degrees of concentration and reasoning that go into different types of literature as well. So it's all a question of degree. So I'm not sure that I'm going to be able to find one quality of mathematics that's only mathematical and doesn't exist at all in other ways of telling stories about the world. But I did give you this list of characteristics which are somewhat distinctive of mathematics.
Another question that maybe is not directly related with the talk, but is related with the topic, is in what ways literature has influenced mathematics?
So I would say that, well, there are some very easy answers to that question. So, for example, if you look at that book of Lucretius I showed you earlier, right? That was more or less in Europe anyways, one of the early exposition of atomism, right? But it was definitely literature. It's poetry, and most of the people in classics departments read it as poetry. There's examples of Latin language and beautiful poetry and so on, right? But that was extremely important in so people say, historians make up stories as well, so it's hard to get the accurate story. But it was very important in 17th century science, to people like Bacon and then to people like Galileo and so on, right? So you can imagine that it's easy to draw the inference that this definitely influenced mathematics. So that's one kind of answer, right? Another way, of course, is in our own lives, right? This is more indirect, but presumably you are having this seminar because you're all interested in literature, and literature that you read presumably changes your life, right? So how can you say it doesn't affect your mathematics? Thanks to everybody for your attention.
We are going to have, perdón, vamos a tener nuestra próxima conferencia en, en 2 semanas y va a ser sobre el 27 de mayo y va a ser sobre Mathematics Beyond Music for a Conscious Interpretation, Conversation Concept. So, vamos a tener una conferencia y un concierto de una matemática que también toca el piano y nos va a hablar sobre la interacción entre música y matemáticas en ese sentido. Nos despedimos de ustedes y hasta la próxima. Thank you.